Okay. For this, what's the first thing we have to do with the differential equation before we can solve the differential equation? Times it by dx. Hello? Yes. Yes, I'll send him over there. All right, you're welcome. Miles, the college advisor needs you in guidance. All right, so multiply by dx. I've got dy equals y squared minus xy squared dx. All right. And what's our goal in doing this? What are we trying to do? Why did we need that dx to be on the other side? Y is on one side, x is on the other. How are we going to do that? Okay, if I subtract the y squared, I'm gonna chase this rabbit for a second. I would not write this down. If I subtract that y squared, this dx goes with the whole side, right? We're multiplied. So that means that, like, this is a y squared dx, and I'd have to subtract y squared dx. Is that what I want? No, because I don't want that dx to go over to the other side. Close. If I just take out a y, I'd still have one left, but this right here, this xy squared, it's just the x and the y squared, so that really could just be written like this, y squared minus x squared y squared dx. Yes, so we can pull out a y squared. Like that. And now, how can we get rid of the y squared? Divide it. Most of the time on these, other than maybe like moving something over to the other side at the beginning, most of the time you want to move your x and y stuff by multiplying or dividing. Not so much by adding or subtracting, because that usually causes an issue with your dx. So I could write this as dy over y squared, but if I'm getting ready to integrate, what would be easier than having that y squared in the bottom? I could do 1 over y squared. There's something even easier. Let's do negative exponents on that. Okay, here. All right, we are now going to integrate both sides. So to do that, we increase our exponent by 1. That's going to give us a negative 1. We'll divide out front by negative 1, which will give us a negative here. We could put a plus c, but I'm just going to save it and put it on the other side. On the right side, we'll get x minus, and then we'll get x to the third. We'll have a 1/3 right here. And what do I need with it? Plus c. If you don't put that plus c right there, right now, then you will not get, like if this is for response, you will not get full credit. As you can see, that doesn't really look like our answers very much over on the other side, but hopefully we've got some work we can do. One thing you'll notice about all your answer choices, what are they solved for? Y. So let's solve this equation for y. Maybe that will help us. So this is like negative 1 over y equals x minus 1/3 x cubed plus c. How would I solve that for y? It's not a natural log for this. Because if we were integrating at this point, it would be a natural log. But we've already done that. Yeah, we're going to multiply by our y. And so that will be negative 1 equals y times x minus 1/3 x cubed plus c. And then I can divide by the x minus 1/3 x cubed plus c. So, where I'm going to go up here, run out of room, y is going to equal negative 1 over x minus 1/3 x cubed plus c. Now, that doesn't look a whole lot like what I've got. If I had to guess, I'd do B, but maybe A. I'm not 100% sure. Here, what we need to do is we need to find what that C value is. And they gave us this information right here. Y of 3 equals 1. So we got the 0.31 that we can plug in. So we're going to plug in 1 for our Y. And we're going to plug in 3 for our X's. 3 minus 1/3 times 3 cubed plus C. Okay, so that is going to give me 1 equals negative 1 over 3 minus, we got 1/3 times 27, and 1/3 of 27 is going to be 9, so it's going to be minus 9 plus C, so 1 equals negative 1 over negative 6 plus C. How are we going to solve that for our C? Multiply by negative 6 plus c. You cannot solve for something when it's in the denominator of that fraction. So we're going to multiply both sides by that denominator. And since we just have a 1 over here, we just get negative 6 plus c equals negative 1. We need to add the 6. So c equals 5, which means that our equation that we're getting is y equals, I'll that slide up like that. Y equals negative 1 over x minus 1/3 x cubed plus 5. Now, if we were on a free response question, this would be our answer and we would stop here. We wouldn't do anything else with this. This would be done. But we are not, and that's not an answer choice. So, which one of these do you guys think it matches, and how do you get it to match?
B.
Okay, B is going to be correct. What could I do to my answer that I have now to get it to match B?
You like multiply by 3.
Multiply by 3 on top and the bottom. And if I do that, I'll get that negative 3 on top. I'll distribute the 3 to everything in the bottom, and I'll get 3x minus x to the third plus 15. So B would be our answer. Again, on a free response, you are not, I would not even encourage you to do that because you might mess it up and then you might lose the point. So, yeah, I mean, definitely could rule out some answers. I haven't tried it on this one. You may have already, but that could be true for this equation, but it could still be wrong. Because it might, now if you took the derivative of each one to make sure you got this derivative and plugged this number in to all of them to make sure that you got 1, then yeah, I think that would work, but it would probably be more work than doing it the other way. But if you were unsure, it would at least like rule some out, because if these do not equal 1, then it wouldn't be the correct answer here. Okay, questions? All right, let's try another one. First, this is, example 2 is like an example of what a free response differential equation question looks like. One of your, that first one I think on your FRQ assignment for this week is a differential equation problem. And sometimes they ask for slope field, sometimes they'll ask like some little things like a slope tangent line or something, but then the bulk of the question is solving that differential equation. So this one asks us for a slope field. So for a slope field, remember we got these 9 points. You don't have to, but if you need to, x, y, dy, dx, you can make yourself a chart. And the points that you have are 1, 0, 2, 0, 3, 0, 1, 1, 1, 2, 1, 3, 1, and then x, y, dy, dx. 1, 2, 2, 2, 3, 2. All right, so those are the points that we're plugging in. So if I plug in 0 for my y, 0 minus 1 over 1, I'm going to get negative 1 for that. So right here at 1, 0, I should have a slope of negative 1. 2, 0, I'm going to get 0 minus 1 over 2, so negative 1/2. And so that's going to be less steep than the one before it. And then for the third one, I'll get 0 minus 3. I'm sorry, 0 minus 1 over 3. So negative 1/3, even a little less steep than the one before it. For the next 3, the numerator is going to be 1 minus 1 over 1 for that one. That's going to give me 0. Here I'm going to get 1 minus 1 over 2, also 0. 1 minus 1 over 3, also 0. So all of these have a 0 slope. We'll have horizontal lines for that. And then we're going to have 2 minus 1 over 1, which will give me positive 1. So we have a slope of positive 1 for this first one. We're going to have 2 minus 1 over 2, which will give me 1/2. So positive 1/2 here. And 2 minus 1 over 3, which will give me 1/3. So positive 1/3 for that. The table is totally unnecessary. If you are really good at doing this in your head, do it in your head. You'll be much quicker if you do that. But you can make it if it helps you. There. All right. So it says let y equal f of x. All right. And so I want you to pay close attention to this. Let y equal f of x be the particular solution to the given differential equation with the initial condition of f of 3 equals 2. So y equals f of x would be what we get if we solve the differential equation and we solve it for y. And it has the initial condition f of 3 equals 2. But then it says write an equation for the line tangent to the graph of y equals f of x at x equals 3. Use the equation to approximate the value of f of 3.3. Is this asking us to solve a differential equation? What is it asking us to do? What? It's a tangent line, which we'll use the derivative for. But we have to find the derivative. The derivative is the differential equation itself. dy over dx equals y minus 1 over x. So this is just a tangent line problem. We've done a lot of tangent line problems, so we're pretty good at tangent line problems, right? So for a tangent line problem, you need 3 things. You need a point. What is the point for this one? 3, 2. Okay, we get that from right here. All right. We need a slope. Okay, the slope is the derivative. The derivative is your differential equation here. It is dy over dx equals y minus 1 over x. So we're doing dy over dx, and we're, let me write over here just so I can see it on dy over dx equals y minus 1 over x. So we're plugging our point into that derivative, right? To show that you have done this, you're going to put the such that line, you're going to say xy equals 3, 2, like this, and then you'll do 2 minus 1 over 3, which is going to give us 1/3. So that's our slope. And then we will have our equation. That's the third thing. And our equation is y equals 1/3 x minus 3 plus 2. Everybody okay here? We've done this many times. It's just not been in conjunction with the differential equation. But then they also asked me to approximate f of 3.3. What do I have to do to approximate? Plug it in for x. Use a squiggly equal sign because it doesn't actually equal this. We're doing 1/3, 3.3 minus 3 plus 2. Do I have to do anything else? I can leave it. I'm just going to leave it. I don't even like to. But you got decimals mixed with fractions there. And it's probably in our best interest just to let it be. Because they don't ask us anything else about it, right? They don't ask us if it's greater than or less than anything. We don't have to have that number. And this is a FRQ, so I'm going to leave it there. No, 0.3 is 3/10. 1/3 is 0.3 repeating. So you're going to get like 1/10 plus 2, you get like 2.1 is your answer, I think, if you do that. I think. But I would leave it just to be safe there. Okay, now this last part says find the particular solution y equals f of x to the given differential equation with the initial condition f of 3 equals 2. This is the part that's asking you to solve the differential equation. Because they have said find the particular solution y equals f of x, and this is how they'll word it most of the time. That right there means you must solve for y at the end of the problem. So like your answer has to be y equals. On the problem we just did, we knew that because our answer choices looked like that. All our answer choices were y equals. These don't have answer choices, so that is the way they're telling you that you have to solve for y, and if you don't, you won't get the full credit for the points. All right, so our differential equation is dy over dx equals y minus 1 over x. What's the first thing I should do? Times the dx. I'll get rid of that. So now I've got dy equals y minus 1 over x dx. What next? What do you think, Valeria? You can, but it's not, it's going to make it where you got like x's and y's together that are going to be hard to get over to the other side without, to separate them. So I wouldn't do that, although it is it would be a legal move. Do I want my x to be over here? No. I want the x to stay where it's at. What do I want to get rid of? The y, right? I want the y to be over here. But what's going to happen here? Somebody else is going to guidance. Hello? Yes. You're welcome. Kendall, they need you in guidance now. So they said bring your laptop. All right. The y needs to be moved over to the other side. The y is kind of connected to that minus 1, and you're not going to be able to separate the y and the minus 1. What you can do is multiply by 1 over y minus 1, which would cancel that there. So we will then have 1 over y minus 1 dy equals 1 over x dx. Okay, everybody with me here? Okay. All right. So we have them. We have these separated now. We need to integrate both sides. So on the right side, what am I going to get when I integrate? Natural log. On the left side, what am I going to get? It's going to be a natural log. I got to do a u/du substitution there, but it's a really tiny one, right? Like, I'm just going to kind of, in fact, I don't even know if I'd write it out here. The u here is y minus 1. What's du? Just the dy, right? It's already there. So I'm going to take, this is just going to be like 1 over u, and then I'm going to integrate that. So I'm just going to get natural log of y minus 1, right, when I do this. So I'm going to integrate both sides. I'm going to get natural log of the absolute value of y minus 1. The reason I can kind of do that without a u du is because my du was dy, which was already there. So I'm just kind of doing, is that okay, or do I need to go back and put the u in? I'm kind of doing that part in my head. And then this is natural log of the absolute value of x. And I'm going to put my plus c over here on this side. Now, you have some options here. I didn't really give you the option on the last one. I just went ahead and did it. You can solve for y right now, or you can solve for c right now. It does not matter which one you do first here. Sometimes it is easier to do it one way rather than the other. Let me look at, what's my point? 3, 2. I'd probably solve for y first on this one, just because you're going to get like, well, that actually, yeah, I think I'd solve for y first. Let's solve for y. So if I want to solve this for y, I'm trying to get that y by itself. What have I got to do to get rid of that natural log? E to the power. So e to the power here will cancel that natural log. E to the power here. Does it cancel the natural log? Not exactly, because I'm going to do a little thinking bubble up here. What this is, because of the plus c, this is e to the natural log of the absolute value of x times e to the c. But what can we call e to the c? We can still call it c, right? And then when I separate these into two different things with two different bases, these can cancel, and I get absolute value of x. However, if c is an unknown number, like that absolute value means the sign of that doesn't really matter, but if c is unknown, that sort of takes care of my absolute value for me, because c could be positive or negative, which would change the sign. So most of the time that c right there is just going to sort of get rid of your sign. So I've got y minus 1 equals cx, and I'm going to add 1 to both sides. So y equals cx plus 1. Okay, you are almost there at this point, but they asked for the particular solution that goes through 3, 2. Is it 3, 2 or 2, 3? 3, 2. So you need to find that c. So I'm going to move over here. We got the point 3, 2. We're going to plug in 2 for our y. We got c times 3 plus 1. And we're just solving for that c. So I'd subtract 1. I got 1 equals 3c. I'll divide by 3. C equals 1/3. And so y equals 1/3 x plus 1. That's my final solution there. Question? The x plus 1, where it came from. I'm just taking this equation that I had right here and plugging that 1/3 back into it. Okay, so there's a lot of steps there in that. These are usually worth 4 or sometimes 5 points. The first point is going to be for separating those variables. So if you get to 1 over y minus 1 dy equals 1 over x dx, you'll get a point for that. The second point is going to be from integrating. Sometimes it's actually 2 points there for like integrating the left, right, and then integrating the right correctly. A lot of times on these problems, there is a full point for including the plus c. So like that third point might just be that you put the plus c there, so you do not want to forget it. And then you'll get usually a point for solving for y and a point for finding the correct c value. So these cost a lot if you don't get them there, but there's a lot of potential for points on these. Okay, questions? Okay. All right. So the general solution to the differential equation dy dx over x minus y is y equals plus or minus the square root of x squared plus c. Let y equal f of x be the particular solution to the differential equation with the initial condition f of -2 equals negative square root of 2. Which of the following is an expression for f of x and the domain for which the solution is valid? Okay, so this one is not asking you to solve the differential equation. They've already given you the answer. The answer is y equals plus or minus square root of x squared plus c. Our particular solution is -2 negative square root of 2. Now, we can plug in and solve for c, but is that necessary in this particular problem? What are we going to get for sure? We're definitely getting -2 for our c, because if you look at your answer choices, all of them have a -2. So if they did not all have -2, we would need to plug in and find that value for c, but we don't need to here. So this one's kind of tough because we have to decide between these positives and negatives and all of this stuff, right? So if we think about what's happening here, we know we've got f of x equals, we may or may not have the negative here. We know we're going to have x squared minus 2. Okay? So if I plug in a -2 right here, like it wants me to, is there any way I can get a negative square root of 2 as my answer without having a negative on the outside? If I end up with a negative on the inside, it would give me an imaginary number, right? So it's definitely not B, and it's definitely not D. Because to get that negative square root of 2, I have to have the negative on the outside. I'll have to check my solutions for this, I might. Because I can see, but also thinking there might be a trick. Okay, it's C. All right, that's what I was thinking. I just needed to double check. Now, it also asks about the domain for that. Oh, actually, if I'd looked closer, I could have definitely told you it was C. All right, so it's asking about the domain for this. For the domain of a square root, what's going to give you a problem with a square root? Negatives under the square root, right? So whatever is under that square root has to be greater than or equal to 0. So x squared minus 2 has to be greater than or, why not equal to? Okay, I don't really know why it's not or equal to, because you can take the square root of 0 and it's 0. But obviously they don't have an or equal to, so we're not going to put or equal to. Greater than or equal to, or greater than 0. So if I do x squared is greater than 0. If I square root both sides, what we usually do when we square root both sides, when we have like x squared equals 0, actually with 0 it wouldn't matter. Let me do x squared equals 1. If I do x squared equals 1 and I square root both sides, I will have x equals not just a 1, but a plus or minus 1, right? Now, it does not make sense to do a, I'm sorry, my 2 went away, didn't it? That should have been 2 I'm square rooting there. It does not make sense to be greater than or equal to a plus, or greater than a plus or minus square root of 2. That does not make sense to do it that way. Another option you have for this, I can also just say absolute value of x would equal 1, because that would mean it could be a positive 1 or a negative 1, right? So we can say absolute value of x is greater than square root of 2, which is C. We also should note it can't be x less than negative square root of 2. Actually, that's part of it, but it's not the complete there. So this will be our answer for that. All right, let's see. We didn't get to 4, which is another differential equation problem. You can definitely still do 1. You can still do 2. 3 is very similar. I think you should still be okay for your homework, even though we did not get to that last problem. So the homework is at the end. It's 4 problems, although one of them is a free response question, so it's a little bit longer. So do that for me.